All right, this is where we were last time, right? We were talking about the sphere class. And for the sphere class, it was going to be like the same idea as the circle, but we're adding a couple more bells and whistles, like it includes an x, y, z coordinate, right? That was kind of the idea. So there's our constructor. Any questions about the constructor? Now's the time to ask. No? So what does it have? It takes 3 parameters, or 4 arguments, pardon me, although self is there, so it's kind of misleading, right? X is x, y is y, z is z. So these 3 pieces of information correspond to like a point, the center point of the sphere, and this is the radius of the sphere. All right? So with this, we can go down here and say my equals a sphere at location 1, 2, 3, and it's got a radius 5, because why not? Print my sphere. We see this. And whenever we print out an object, Python doesn't know how we should print this out. So Python's just going to be like, it's a sphere here, right? It's just some default what happens when you print it out. So there's us creating the sphere. And remember, when we type the class name, this is how we like instantiate an object, how we create an instance of the sphere class. And this will automatically call an it. Now you might look at this and be like, why did you not say like sphere dot like this, right? Like that's the method. Well, because that's not how you do it. This is how you do it. All right? Yeah.
So to get the attributes, I guess I'll call them in a class, you have to have them inside a constructor.
Well, not necessarily, but stop. I know why you're asking that question, but try not to like generalize it too much at this stage, because, or try to find like a rule. It doesn't have to be. I can create another method that can just arbitrarily create additional attributes. They don't have to be in the constructor, although often they are. But a big thing is like, not all attributes need to be passed to the constructor. Sometimes, like think back to the circle example, how with the radius, and we talked about the pros and cons of that design, but you can give it a radius, and you can know the diameter, the circumference, and the area, right? So you could calculate those and assign those to attributes, even though you never passed it to the constructor. And like if you make a list, you make a new empty list, for example, right? When you make a new empty list, you don't say like, here's a list and it's got a size of 0. You just create an empty list and the list goes like, well, it's new and empty, so its size is 0, right? Yeah.
Makes sense.
So a big point, because this is often something that throws people off, is thinking that there's like a one-to-one, like they have to be here in order to be attributes. No. No, 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 no. That's not true at all. Often they are, but that's not like a rule that you should be following at all, okay? So good question.
Thank you.
All right, there we go. And what methods do we want? Well, okay, we've got a couple of basic geometry ones, right? There. Diameter, surface area, and volume. Diameter, well, it's just radius times 2. Surface area, okay, great. Volume, that's that. How did I know this? I couldn't remember. I looked them up and plugged them in. Okay, but now that those exist, I can now say my sphere dot, well, oh, and before you can access the attributes by just like this, right? But note, this is like a variable, right? And it corresponds to that variable there, which it's an attribute because it's assigned to like an instance. It belongs to that instance, that value. Notice that when I call the attribute, there's no parentheses here, right? Because it's not like it's a function. It's just give me this variable, give me this value from that thing. But if I want diameter, that is a method that has to calculate and return the value. If I do this, it's just going to say, well, that's just some method, right? We have to call it with the parentheses. Just like with functions, right? If you ever forgot to put the parentheses next to your function, Python will just be like, well, it's a function. Okay. Any questions about these ones? Okie dokie. Now, I think this is like basically where we left off last time, is this method. Distance between centers. So, oh, yes.
Hey, how are you? So, I can't seem, while you're talking, I'm fiddling around with like trying to get it to print different parts of my sphere, like print a sphere dot radius.
Mm-hmm.
It's saying that I've created the object, but in like the function, in the next box of code where I'm trying to define what everything is, I have a sphere equals sphere, yes with a capital S, open bracket 1, 2, 3, 4. And the error I'm getting is, it says sphere, open bracket, close bracket, takes no arguments.
Do you have an init?
In the function above, I have import math, class sphere, capital F, capital S, def, init,
Is it init or int?
init.
I-N-I-T, you confirm that?
Yes,
Okay.
confirming. Open bracket self, x, y, z, radius, close bracket, colon.
Mm-hmm. Okay. Did you run that cell before?
Yes, and it works.
All right. Well, that's not, in general, this type of question we're not going to be able to figure out like this, right? So this is a question for like office hours or something. Yeah.
I just wanted to ask, you pulled those functions from, like, you copy and pasted them in?
Yeah.
Okay, and then you can still call them below or in a different line, right?
Yeah, but I have to run this, like rerun the cell first. Otherwise, Python won't know that they're actually there. And then I go down here and I can run this cell and it works just fine. That's your question? Perfect. Other questions? All right, so what is this one doing? Well, if we look to it, this is a method that I will call on an object. But it has another parameter. I'm calling it other, okay? And it's going to be a sphere. Now you'll notice with the type hints, it's in quotes. And the reason that it's going to be in quotes is, at least with like the current version of Python, maybe they've updated this, but in at least a recent version of Python, you can't have a type hint for a type within the class that you're writing. It's like, well, it's defining it in itself, so it's kind of weird. So this, we just don't. We put it in quotes. It's like a cheesy way to just add a type hint where it'll just shut it up if like that type doesn't exist. Anyways, there we go. It's going to take another sphere. And you'll see it's calculating Euclidean distance in 3 space, right? It takes the difference in the x's, y's, and z's, all squared, sum together, and the square root of it. That's just Euclidean distance, okay? But you'll notice I'm saying self's x minus other x. Because remember, the way I would call this is I would say like my other sphere equals a sphere. 3, 2, 1, 5. No, 2. Okay. Distance between centers, my other sphere. There. That's the distance between the centers of those spheres. Why? Well, look, when I call it like this, where I'm saying my sphere dot distance between centers, my other sphere. When I do it this way, self and my sphere are aliases. Other and my other sphere are aliases. Why? Well, because it's based on like which one am I calling it on, that's the self, and what did I pass to it calling it other, that's the argument. I can get the exact same answer by saying by switching, right? Because it doesn't matter who I ask. The distance from A to B should be the same as B to A, right? But now when I call it this way, my other sphere is the self and my sphere is the other. So it all just depends on how we are asking the code to do its thing. Is that clear? Okay. Yeah. Perfect. All right. Yeah, perfect. Okay. What is this? Yes, this is just emphasizing the self like we just did. Perfect. Okay, you may notice that the other is a string sphere as opposed to just sphere, just like how the function's return type is a float. Yeah. This is because sphere class, as far as Python is concerned, is not defined yet because we're defining it within the class. That's just a little gotcha with the syntax. Now here's one. Here's an interesting one. First, let's make sure we understand like the geometry. Now you might say, hey, geometry isn't part of the class. No, but yes, because you have to understand the problem in order to implement it. So let's say I want to calculate the distance between the edges. I'm going to draw this in two-dimensional space because it's the best I can do right now. But if I have a circle, right, and another one over here, and I can calculate like this, all right? I have a method. Can you see that? Can you see it better? Perfect. I have a method that will tell me this distance. This is like dist. Distance between centers, right? I can do that. Now, I don't want the distance between centers. I want the distance between the edges of the spheres. Okay? What are you doing? Slowly creeping them forward. Yeah. I shouldn't have said anything and see how far you get. So if I know this, how can I find the distance between the edges? Who can tell me based on what we know of this class so far? Shouldn't be a trick question. You should be able to figure this out. Come on, you're in university. Yeah, is that what you're going to say?
Yeah, I was going to say find the full distance and then subtract 2 radius.
Exactly. So you take the full distance between the centers minus this, which that'll be that circle's radius. Because if I want the distance between centers, it's the straight line. And the straight line from the edge of a circle to its center is its radius, right? So R1 and R2. So really, we just want distance between centers minus R1 minus R2, right? Right? There. Perfect. Now, how are we going to implement this? I could redo the calculation of Euclidean distance, but look. I already have a method, self distance between centers. So what I'm going to do is I'm going to call distance between edges, takes another. I'm going to figure out the distance between centers, which is a method I already defined to get the total distance, minus my radius and the other one's radius. That's it. Return that value. But you might notice I have to say self in front of distance between centers. Now, hopefully this makes sense. First, if you ever want to call a method that is defined for an instance of the class, like all of these are, it needs to be accessed via a reference variable to the object you want to call it on. Self, in this particular case, right? Self. But also, like, let's think about this intuitively. If I don't have self and you jump up here, right, I want to call distance between centers. If we don't specify self, what the hell is self going to be? Right? Like it has to have a self. Now, by the way, okay, let me finish that point and then I'm going to bring up the question I was going to ask, right? So there's that, great, perfect. Okay, that's basically it. Is this clear? Is it's the total distance minus that, well, that's the distance between edges. Cool. Now, raise your hand if you have experience with Java. Okay. So, for the 2 people in here with their hands up, did you do like object-oriented-y stuff?
No.
Like, You kind of have to because it's Java, everything's an object, but like, did you ever like start defining your own classes? No, did you? No, okay, then perfect, that's good. Because it could create some confusion right now because in Java, they have this similar idea to self called this, but you don't actually have to include it. It's this whole thing. Well, that's a next semester thing, so we don't need to worry about it. Cool. All right. And then we have overlaps. Now we want to know, do two spheres overlap? Okay? And how are we going to do it? Well, this will return a Boolean. I want to know, given two spheres, are they overlapping? And all I'm going to do is say like, well, what's the distance between the edges? And if the distance between the edges is less than or equal to 0, then we'll say they're overlapping. Now, I suppose if the distance is 0, are they really overlapping or are they just touching? Edge case, whatever. I said yes. If we could stand here and argue on whether or not that should be less than or equal to, I suppose we could. That's a design decision, but kind of not the point. So like, well, why does this make sense? Well, okay, would you agree if two spheres, if the distance between their edges, let's draw what it would mean for two spheres, circles, what I'll draw, right? How could their distance between edges ever be negative? Well, if I've got a sphere here, and I have a sphere here, right? Well, that's the distance minus this. We're going to have a negative number, right? If they're overlapping, as you can see. To do a less extreme example, right? This minus this, well, we've got this left over. It's a negative number. They're overlapping. They're touching. Okay? Yeah. So that's how that one works. But this is making use of calling the already existing functions, the methods. This is not a new idea. We've been doing this for a month and a half with functions, right? You reuse the functions whenever you can. That's a good thing. We like that. But now we're using it within classes and having methods within a class call other methods within the same class to do what it's got to do. Very normal behavior. Questions, 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 questions. Now, there are, these are also called dunder methods, and I hate that word, so I don't call them that. I call them magic. I don't even like magic methods either, but whatever. Does anyone know why they're called dunder methods? I don't expect you to. I was just curious if anyone knew. These are all the ones that have like the double underscores. So like dunder. I hate it. Anyways, there's a bunch of magic methods. They are, yeah, you're excited about this.
You said you could call them indirectly through some other syntax.
Bingo, bango. So, magic methods are special. To be clear, they're just methods. But in general, they are methods that are commonly used across a lot of different classes, unrelated classes, like they're a common thing you might want to do. For example, the initializer, the constructor. Every class is going to have a constructor, okay? So it's like this magic one. We call it magic because there's something special about it, all right? And we don't call the constructor directly. We don't do that. We access the method via calling the name of the class, which then it automatically calls the magic method init, okay? There are a bunch of other magic methods out there. In fact, let's have a look. Python magic methods list. Oh, come on, there's more than that. Oh yeah, it's like in a, yeah. Okay, come on. Whatever, there's a lot. you can start to see there's a bunch here. If we keep going, there's like a long list of them. We're not going to cover them all. Some of them have very special meaning, but of these, there are a few that are so common and important that it's worth talking about. If you were in lab yesterday, we did talk about one of these specifically already, because I gave you a little bit of a sneak peek of today's lecture. But, okay, so, all right, let me make sure, okay. There exists some number of special magic methods, all right? You don't call these directly, you call them indirectly through some special syntax. And init, the constructor, which isn't really a constructor, but it is a magic method. You never call init directly, you call it via just the class name. And Python knows, okay, if they ever call like the class name, that means run the constructor, okay? So yeah, when I call sphere, it actually goes and runs the init method within the sphere class, okay? Okay, okay. There are a bunch. Oh, perfect. Here, I have a list here. Oh, no. Oh, yeah. There's all these. This is great. GT. Who wants to guess what that stands for?
Great time.
Very close. He said great time. It's close to that. It means greater than. What do you think GE is? Greater or equal, yeah. So there's a bunch for comparison operators. And here's a sneak peek of what we're doing what we're going for here is like greater than you would call with the greater than symbol. If you ever had two instances of a class that you're writing and you implement this method, this is the code that gets run if you use the greater than symbol or the greater than or equal to or less than, et cetera, et cetera, et cetera. But more on this in a moment. There are a bunch. Two that we're going to care about right now are EQ and repr. Okay? These are the two, these are big ones. EQ is a method that we write, specifically we override it. I'll explain what that means in a moment. We override the EQ method to tell Python what does it mean for two instances of this object to be equal. Okay? So in the context of the sphere, if I write the EQ method for the sphere, I would say, here's what it means for spheres to be equal. Okay? Think about it like this. Think of the list class. You've used the list class. If I have two lists, what does it mean for two lists to be equal? If they have the same elements in them in the same order? Yeah, okay. Someone had to tell that to Python. Here's what it means for two lists to be equal. If Python doesn't know, it doesn't know. Let me show you what I mean. Within this class, there is no EQ method that I wrote. Now, it turns out Python is sneakily adding an EQ method to this class for me already. You will never see it, but it's there. Remember how last time, or maybe it was 2 times ago, I showed you if you start defining a class without an init, you can actually create an instance of the class even if you don't write the init. Let me show you again real quick. I'll go down here, class, let's say like def some function self. Okay, and I can go down here and be like a equals some class, doesn't take any arguments, and then print a dot some function. Really it should be called some method, but whatever. It works, right? A super simple little class. I can make an instance of it. There we go. If you think to yourself, well, hold on. You say whenever you call like the name of the class like that, it goes and it runs the init method, the magic method. There is none. There is. If you don't write it, Python adds one for you. And it's like the default behavior. But what we usually do is we say like, well, look, that default behavior that we get for free if we don't write the method it's not going to work for me right now. I need a custom one for my object. So we override the one we get for free with the one we want. All right? It's basically saying, like, look, if you don't write it, here's the default initializer. If you write it, we overwrite it. That's it. We just ignore the one you get for free and we use the one that you wrote. Yeah?
How would it look if we used the init?
How would it look?
Yeah.
Well, it would depend on really what we want, right? But I could just be like, I don't know, def. No. There. Now if I do this. Oh, it's because I didn't. There. This should work. There we go. Well, why is that wow running? Well, because on this line of code, it jumps up, it runs this, oh, it prints out wow. If you're thinking like, well, why would I want to do that? You probably don't. This is just a contrived example to show you that, like, yes, it's running that code. Cool? All right, let's get rid of this. We don't need it anymore. Now back to here. Okay. I'm going to do this. I'm going to say sphere. Okay, look, I made my sphere and my other sphere. They are, for all intents and purposes, the same. Would you agree? The sphere at location 1, 2, 3 with a radius 5, sphere location 1, 2, 3, radius 5. They're equal, right? They are exactly the same. Okay? So, it would be reasonable to say, well, if all their values are the same, my sphere equals my other. My other sphere. False. Right? I'm asking, hey, are my spheres equal? And Python is saying, no. False. That's not true. If you're looking at this, but they are. They're the same. Right? It's because we never told Python what it means for two sphere objects to be equal. That's what the equal method is for, is where we say, okay, what was that? You did, I'm guessing you didn't mean to do that. I don't know if it, you might want to get it wherever it landed. It landed over there somewhere. I think it landed on him. Whatever, like I just saw it a last, I paused and I just see like, boop. Did you get it? There you go. And it made this funny little like this tiny little noise. Anyways. All right, so yeah. But I also said, by the way, Python gives you an equals, like an underscore eq underscore for free, right? If you don't write it, you get one for free. So the one I get for free is still saying this is false. What gives? Well, who wants to guess what the default behavior is for equals, for the EQ method? Who wants to take a wild guess? I don't expect you to know, but you could probably guess it.
If they're like actually the same, like if it has the same
Sameness.
That's what it is. Thank you.
If they're what? What did you say? It's going to check sameness. It's going to check, are they aliases?
That's the word.
So if I were to say like A equals my other sphere, we're creating an alias. And then if I say my sphere equals A, true. So the default behavior for the EQ is sameness. But look, for my needs, that's great and all. But for my needs, these should be equal. Right? If they exist in the same location and have the same radius, they're equal. Okay? Now, look, like I said before, when we are writing our own class for our needs, we are God. We get to say, this is what it means to be equal. Maybe for your needs, for two spheres to be considered equal, they don't actually need to be in the same location. All that matters is that they have the same radius. Right? Or maybe, for your needs, I actually don't care if they have the same radius. What I care about is if they're in the same location. We get to say, we are defining what equality means for our sphere objects. Oops, just a reminder. Maybe we can get rid of that. Yeah. My sphere, true. Okay, cool. So, now, the funny thing is though, if you're dealing with primitive types, equals equals just is like the sameness doesn't really matter. It's just checking are the values the same. But as soon as you're dealing with like objects and references, it's going to work kind of a little differently. So yeah, what does it mean for two things to be equal? Well, here's what I'll say. And by the way, before, like, we will revisit this EQ. This is a really bad EQ method, okay? We are going to improve this quite a bit. But for now, I think it gets the point across. So, what does it mean for two instances of the sphere class to be equal? If self's x and others' x's are the same, their y's are the same, their z's are the same, and their radiuses are the same. If that's true and true and true and true and true, true. If any of them are not the same, false. Fair? Reasonable, right? Yeah.
Is there any way that we can trick it, or not so much trick it, but make it seem so they appear to be the same, but it doesn't, or it returns false? Does that make sense?
Well, I mean, we could, if we want, like we could just say this, right? We could effectively lie, right? Without having like a specific case in mind, it's hard to come up with like an answer. But like, in principle, yes, right? But it would really be depending on what you want to do. So for our needs here, this is what we'll say, they're equal. And if I run this, and I go down here and I say, we can get rid of A. All right, so let's say like my other sphere. Now if I run it, it's true. Because they're all the same, yeah.
Since it's a method, does that mean you could just put anything in there?
Yeah.
I mean, obviously it would not be like a good thing to do, but okay, hold it.
Like this. And it's going to say, remember how like 2 seconds ago I was like, we're going to improve this? That is precisely why we got to improve this. But we're not going to do that right now. But very good point and observation. For those of you that were like wondering, like, well, what? Like, hold on. Other. What if you give it something that's not a sphere, right? Like if I put in a 44, it crashes. Really, do I want it to crash? I probably want it to be like false. The sphere and the number 44 are in fact not equal. You know? Yeah. But we'll fix this shortly. It's a pretty easy fix, but we will fix it shortly. My other sphere. Cool. And if you don't remember, there was also that operator we talked about before. Is operator. Remember? Is tells you if they're literally the same thing. So basically, the default EQ method is using is. So although they are equal, they're not the same thing. But my sphere and A are equal and are the same thing. You see? There's no magic here other than the magic method. Yeah. Questions, thoughts, concerns, comments about any of this? All right. So there we go. Now look, I said you don't call these by calling the method directly. You don't. You could though. You can, if you really want, do this. And you'll even notice that like the code completion, it's not showing me that method. In fact, it's being like, don't do it. Don't do it. Don't call that magic method. See? And now it's finally like, okay. You can call it like this. Don't do it. The Python police will get you. When you do it, like, give me 1 second. This is effectively syntactic sugar for this. So if you want to argue like, but it's the same thing, yes, but don't make the Python police mad. All right? Just don't do it. You don't. The whole point of the magic methods is that you don't do it this way. Right? The point is to have nice syntax. Cool? I saw you had, someone had a question?
I had a question.
Yes.
It was what you just explained.
Oh,
I
okay.
was just asking if they're technically the same.
They are. They literally are. It literally will override it. There are some like funny cases with some of the magic methods. For example, there is a not, an NE, which means not equals. So you can define what it means to not be equals. And if you have an equals defined, if you don't define the not equals, it simply does not EQ, right? But in funny situations, that can actually be a problem. So it's, don't worry about it. Yeah, I won't get into it now. But there are some cases where it's like, well, it's not actually going to run that one. It's going to run not this unless it is implemented. There's some like funny situations. But in general, in principle, that's the idea. Don't do this. And in fact, should you ever do this? Say no. Say no. Say it. No. Say it with vigor. No. There you go. I like that attitude right there. Yeah, no. In spite of this, I guarantee you there will be several people that will write this on the final exam, and I'm going to lose my mind whenever I see it. It's going to be you. Don't do it. Don't do it. I'm gonna like put something in the marking. If you call the magic method directly, I'm giving you like -20 on your final exam. Just don't do it. That's insane. Like I will call the Python police on you. I will tattle. So don't do it.
Who's the guy who made Python again?
Guido, he's gonna find you. He will haunt your nightmares. Yeah. Anyways, all right, cool. EQ. So you may be tempted to call it like this. Don't do it. Anyways, so there you go. Cool. Now, so this is getting to your question. Like, well, what if you gave it something else, right? Like a circle or a string or whatever. Would it work? No. It'll yell and be like, that circle, you're trying to get at like think of the string example. Hello. It's going to say, hey, that string doesn't have an X attribute. Well, of course not. The sphere does. I mean, maybe the string does, but it's not going to be what you want it to be. So we've got a bit of a problem. But turns out there's a simple solution. There are a number of ways we could actually like address this problem. This is a particularly easy one. But there is an operator, or a function, I guess. There's a couple of ways to do it, but here's one. If other is an instance of the sphere class, that's what this is saying. Is the type of other sphere? If it is a sphere, do that check. If it's not a sphere, they're not equal. Is the string hello in this sphere equal? No, it's not. Why? Well, it's not even a sphere. How could they be equal, right? Now you might say, is there some funny cases? Yes, you could do whatever you want in here. It's code, you could do whatever you want. But here's the simple fix for it, right? Is if I do it like this, and then I go down here and run, it'll now say false. They are not equal. You might, if you think like, well, the crash, yeah, that obviously they're not equal if it crashes. Yeah, but you probably don't want your program to crash. You want it to say, no, they're not equal, right? Is 7 and hello equal? No. That's an answerable question, right? The computer doesn't need to go like, oh my gosh, right? Yeah. All right. In fact, it's arguably something we should do. Okay, yeah. Nothing, you might say like, well, we never defined EQ for a circle. Yeah, but we should, right? And here's how we would do it. The circle class was even simpler. It had one attribute. So if it's an instance of a circle, check if their radiuses are the same. If it's not an instance of the circle, it's just not equal. Okay? Yeah? Cool. Cool. Any questions about EQ? Yes?
Does the instance run with the simple type, like a string or an int?
Well, string is not a simple type, but ints, well, let's see what happens. 5 is 5. True, but it's saying you probably don't want to use that on literal ints. So, yeah. I can still do like A equals 5, B equals A, B. And okay, it's true, they're the same, right? But if I do 5 like this, but they're not the same. But is this saying true? It's complicated. Long story short, don't use this on primitive types. Just don't. That's not what it's for, right? And it's going to act weird in that situation because of some of like how Python works behind the scenes. That's not important for us right now. But an interesting question nonetheless. And unfortunately, we're out of time and we won't get a chance to talk about repr. But repr is effectively how you define, like if you want to print out an object, what do you want it to look like? You get a default one, which is class name at OX blah, 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 blah. But we can override that with more helpful ones. Cool.